Hey, hi, welcome back. So in previous lecture, we completed the soldering of all the SMD components which are present on this hardware. And in this lecture, we are going to do the soldering of all the through-hole components which are present on this hardware. Okay. So in this lecture, this entire hardware will be ready. Alright. So let's start with the soldering of through-hole components now. So the first through-hole component that we are going to solder is basically the potentiometer. And we have discussed every single thing regarding this potentiometer. We have discussed all the theoretical aspects of this potentiometer, and you already know every single thing about it. Okay, so now let's see how to solder this potentiometer on the PCB. Now while soldering the potentiometer, actually the polarity is not a point of concern. Okay. So you can insert the potentiometer in any direction or in any way on the PCB. It's just that in our case, I have actually mentioned where the knob of the potentiometer is. Okay. So that's the reason I have to insert the potentiometer on the PCB in a specific way. Otherwise, while soldering the potentiometer, you don't have to bother about the polarity or the direction, because potentiometer is basically a kind of resistor, and you already know that resistor don't have the polarity. Okay, in the same way, potentiometer don't have the polarity, so you don't have to bother about the polarity in case of potentiometer. Now here I will tell you very important thing about soldering a through-hole component. Okay, and always remember this particular point. Whenever you solder a through-hole component, you have to make sure that that particular component is parallel to the surface of the PCB. And while soldering a through-hole component, you have to apply the pressure on that particular component. Okay, otherwise you can see here this potentiometer is actually not parallel to the surface of the PCB. Okay, it is little bit tilted. That's the reason you have to apply the pressure on that particular component while soldering it. Okay, so this is actually very important thing, because once you solder that through-hole component, then sometimes it will be very difficult for you to align that particular component in parallel to the PCB, because there you have to desolder that particular component, then you have to align that component, and then again you have to solder that component. Okay, so this is actually going to give you a lot of pain. That's why always remember, whenever you will solder a through-hole component on the PCB, first and most important thing that you have to do is you have to make sure whether that particular component is parallel to the PCB. And once you are sure that the component is parallel to the PCB, then you have to start soldering that particular component. Okay, and along with that, you have to make sure that you are applying enough amount of force on that particular component while soldering it. Okay, this is actually very important thing. Now here, if you see, I am actually soldering the header. Okay, debug/programming header, and while soldering this header, if you see, I am actually applying the pressure on the header so that it remains parallel to the surface of the PCB while soldering it. Okay, otherwise it may get tilted while soldering it. So always remember this particular point. This is actually very important point when soldering a through-hole component. Alright, so we are done with the soldering of potentiometer and debug/programming header. Now let's solder the through-hole crystal. Okay, In case of through-hole crystal, actually there is no polarity. You won't find a through-hole crystal who has got polarity. So you don't have to bother about the polarity and you can insert the crystal in any direction. Okay, whereas in case of SMD crystal, in most of the SMD crystal, if there are 4 pads on the SMD crystal, then there will be polarity. So before placing that crystal, you have to check the polarity of the crystal and then only you have to solder that crystal. Okay, otherwise that SMD crystal will not work. Whereas in case of through-hole crystal, as there is no polarity, so you can insert it in any direction. Okay. Alright, so we are done with the soldering of crystal now, and let's cut down the extra leads of the crystal, and along with that we are going to cut down the extra leads of the potentiometer as well. Okay, and the instrument that I am using to cut down the leads, it is basically called as cutter. Okay, so we use it to cut down the leads, extra leads, and along with that we also use it to cut down the wires. Alright, so now let's solder the input and output capacitors of the 7805 IC, and we have already discussed that these capacitors are basically electrolytic capacitors. Okay, and electrolytic capacitors are basically going to have the polarity. Now in this capacitor, if you see this light blue part, okay, this band is actually the negative terminal, and also it's going to have the shorter lead compared to the positive terminal's lead. So positive terminal is basically going to have the longer lead and the negative terminal is going to have the shorter lead. And in case if you cut both the leads, then you can actually identify which one is negative terminal and which one is positive terminal by looking towards the band on the capacitor. Okay, so there are 2 ways to identify the polarity in case of electrolytic capacitor. One is by observing the length of the leads, and the second one is by identifying the band present on the capacitor. Okay, so band part is actually going to be the negative terminal. So now let's insert both the electrolytic capacitors on the PCB, and if you see, we have mentioned on the cell screen which pad is basically positive terminal of the capacitor and which pad is negative terminal of the capacitor. And this is how basically the cell screen is actually helpful while inserting electrolytic capacitor. Okay, so generally people who are going to assemble the PCB, if they are assembling the through-hole components manually, then it's very important to tell them, or there should be some notation on the PCB which will tell them which one is positive terminal and which one is negative terminal. And if you see, in case of capacitor, there is a square pad, okay, that which actually indicates the positive terminal of the capacitor, and another pad is as it is a circular pad, so it's going to be the negative terminal of the capacitor. So in this way also you can actually give the notation for the positive and negative terminal of the capacitor. Okay. Alright, so we are done with the soldering of electrolytic capacitors of 7805 IC. Okay, now let's solder this 16-pin IC base of L29 3D motor driver IC. Now here actually we are not soldering the IC directly on the PCB. We are soldering the IC base on the PCB, and then we will place that through-hole IC on this IC base. The advantage of using IC base is, in case let's say that if your IC get damaged, okay, so you don't have to desolder that IC from the PCB. That will be a lot of efforts. Okay, so if you use a IC base and if your IC gets damaged, then in that case what you can do, you can simply remove the IC and replace it with the some other IC. Okay, so it's going to it's going to make your life easy and it's going to reduce a lot of pain. So whenever you deal with through-hole components, it's better to use the IC base, so that in case if the IC get damaged, then you can easily remove that IC and replace it with the new IC. After that, this is actually very important point that I want to discuss here. Generally, when you solder the through-hole components, while soldering the through-hole components, sometimes it may happen that one of the pad or the hole of the footprint may get blocked because of some reason, okay, or because of some mistake. So in that case, you have to use a solder wick, okay. So it's going to absorb all the solders from that particular point. Now sometimes this solder wick will absorb the entire solder from the hole, but in case if the solder remains stuck in the hole, then in that case what you can do, instead of using the solder wick, you can use the IC base, place it on the footprint, okay, and after that apply some pressure on that IC base, and from bottom side you have to actually clear that hole. So you just observe the process how I am doing it, okay. So this technique is actually going to it's going to be a lot helpful to you if any of the hole get clogged. So you can use this method to clear the holes. Alright, so we are done with the soldering of motor driver IC's IC base. Now let's solder the IC base of 7-segment display driver IC. Actually, I forgot to tell you one important point regarding the soldering of IC base, and I have done this particular mistake multiple times when I was getting started, or when I used to design my small PCBs. What I used to do, I actually used to solder this IC base in opposite direction in a hurry, okay. I don't used to check the notch of the IC base with the notch of the footprint which was present on the PCB, and I used to solder this IC base in the opposite direction, and I have done this particular mistake multiple times. That's the reason I am actually emphasizing on the fact that whenever you solder the IC base, first of all you have to check the notch, okay, and you have to align the notch with the notch which is present on the silk screen, and then only you have to start soldering the IC base. And again, you have to whenever you solder the IC base, you have to place your finger on the bottom side so that the IC base will remain aligned, or it will remain parallel to the PCB, or it will be mounted on the surface, and after that only you have to start soldering the IC base. And most important thing that I will tell you about soldering the IC base is, you solder the two opposite ends or diagonal pads of the IC base. Now here, while soldering the IC base, I have actually not done that, but whenever you solder the IC base, you solder the topmost or the top rightmost pad and bottom leftmost pad, okay. So that will actually fix the IC base on the PCB, and then it will be a lot easy for you to solder rest of the pins or rest of the pads of the IC base. So this is actually very important point. Alright, so we are done with the soldering of IC base for 7-segment display driver IC. Now let's solder the terminal blocks of the motor driver IC. So here we are actually going to connect the motor, okay, on these two terminal blocks, and we call it as green terminal blocks, okay. So that's actually the standard name, and if you want to purchase it from the local shop, then you can tell him that I want 2-channel green terminal block, and he's going to provide you with this particular connector. Alright, so we are now just remained with the last through-hole component of this PCB, which is basically a 7-segment display. Okay, and we have discussed that it's going to have a pin configuration. So you have to make sure that the first pin of this 7-segment display is actually going to the first pin on the footprint. Okay, otherwise the 7-segment display will not work. So that you have to make sure while inserting the 7-segment display on the PCB. And as we are not actually inserting the 7-segment display on the header, so if you do the mistake here while inserting the 7-segment display, then you are going to face a lot of problem. Okay, and personally, if I have to tell you, I have done that multiple times. So from my experience, I am telling you, you be conscious, okay, while inserting the 7-segment display. Otherwise you are going to face lot of trouble and lot of pain. Alright, so now let's complete the soldering of 7-segment display. Alright, so we are done with the soldering of all the through-hole components and SMD components on the PCB. Now let's insert the standoffs on the PCB. Okay, so we have provided the mounting hole for the standoffs. So we will insert all the standoffs on these mounting holes. The purpose of these standoffs is actually it's going to give a height to your PCB. Let's say that by mistake you place this particular PCB on a metal surface while testing, and in that case if the standoffs are not there, then the short circuit may happen, okay, on the PCB, and that may damage your entire PCB. So if you have a standoff on your PCB, then it's always going to give some height to your PCB. So even if there is a metal surface, then you don't have to worry much. Or sometimes, you know, on the table there will be multiple strands of the wire, or there will be multiple threads of the wire, or the terminals of the components. So in case if you place the PCB on those terminals while testing, then again the short circuit may happen and you may damage your PCB or a specific component. So it's always better to provide the mounting holes on your PCB, and you have to insert the standoffs on those mounting holes. Okay, so always remember this point. This is actually one of the most important point if I have to tell you from my experience. Now let's insert the L293D IC in the IC base. Now here actually I will tell you one important thing. Whenever you purchase a deep package IC, okay, dual inline package through-hole IC, most probably those IC will actually not get inserted in the IC base. The reason is the pins of those ICs are actually they are actually little bit spreaded. So what you have to do, you have to bend the pins of those IC. And once the pins are bended, you can actually use the breadboard for that, or you can simply use your fingers to bend those pins. Okay, so you just observe the process, you will understand how I am doing it. And once the pins are bended, then automatically that IC will actually, it will be easily inserted in the IC base. Okay, so you have to use this kind of method if the IC is not inserting in the IC base. However, you need to be little bit careful, because while bending the pins of the IC, you can actually bend the pins too much. Okay, so you have to be little bit careful about that. Okay, otherwise you will damage the IC unnecessarily. So you just observe the process. You need to insert the IC in this particular manner.